Welcome back to this series of Power Electronics Labs. Today we will go through Lab 9, Inverter Control Signal. The contents are 1. Introduction, 2. Circuit and Principle, 3. Building Prototype, 4. Testing Results. Now let us start with the introduction. The purpose of this lab is to build and test a circuit which generating control signals for an inverter. An inverter is a circuit converting power from DC into AC. The output control signals of this lab are two PWM signals, which will be used in Lab 10 to control two half bridges. Each signal will control one individual half bridge. The control variables are 1. AC output magnitude, which is controlled by the PWM duty cycle generated in Lab 7. 2. AC output frequency, which will be determined by output signals in this lab. Now let's look at the circuit of the prototype and its working principle. The prototype consists of three portions: 1. Frequency control, 2. Oscillator, 3. Magnitude control. Here are the working principles of each portion. 1. The frequency control is done by RC circuit, POT4 and EC8. Adjusting the value of the potentiometer, the time constant changes along, which will determine the frequency of the output signals. 2. The oscillator circuit is a Schmitt trigger NAND gate, which will flip the output signal according to the timing set in the RC circuit. The two inverted signals are used to control two half bridges. 3. The magnitude of the AC output of the inverter will be controlled by the duty cycle of a PWM signal. The PWM signal from Lab 7 merges with the two oscillating signals to form the two half bridge signals GA and GB. Now let's build the prototype. First, find the components for this lab. The PCB portion, Lab 9 Inverter Control Signal. 1 aluminum capacitor, EC8 as 10 microfarads. 1 potentiometer, POT4 of 100K, 1 surface mount resistor, R42 of 1K. 2 DIP14 IC sockets. 2 integrated circuit chips, IC7 as 74HC132, IC8 as 74HC08. The recommended procedure for soldering the components are: Step 1. 1 surface mount resistor, R42. Step 2. 1 potentiometer, POT4. Step 3. 2 DIP14 IC sockets, IC7, IC8. Step 4. Insert the two chips into the sockets. IC7 is 74HC132, IC8 is 74HC08. Step 5. 1 aluminum capacitor, EC8. Now the prototype is completed. Let's test the prototype and get the results. Here is a waveform captured from the output of the circuit. Channel A shows the first half bridge signal GA. Channel B shows the second half bridge signal GB. To control the AC output frequency, adjusting the value of POT4. To control the AC output magnitude, adjusting the value of POT2 in Lab 7, which changes the PWM duty cycle. Here is a video clip showing the AC output frequency changing along with the value of POT4. Here is a video clip showing the duty cycle of the inserted PWM signal changing along with the value of POT2 in Lab 7. We complete the lab. Thanks for watching.